So the first thing we want to do once we have our XY line set up is to start picking out all the points. So we're simply going to make a reference line over here. Just want to do it lightly because we don't want it to interfere with our drawing later on. So our first point, which is A, is across 140. So there. It's up 10. And it's down 15. So that's point A. So once we've all the points plotted, we should end up with two different planes. It looks something like this: plane ABC in red and plane DEF, which I've outlined in green. So once we've got our planes set up, the first question is to determine the line of intersection between the two planes. So the way we want to do this is we want to take a horizontal line across on one of the planes. So we'll go from point F, and we're just going to bring that, as I said, a horizontal line straight across the plane. Next thing we want to do is we want to drop that down. So it's in the elevation, it's contacting the line DE. So I'm going to drop that line down to DE in plan. And we're going to join it back to F. We bring these 2 points down also, and we want to bring them down to where they cross plane ABC. So this first one crosses it on line AC. Again, bring it down to AC. This one crosses it on line AB. Bring that down to AB. And once again, we're just going to join them up. And where the two intersect is the first point on our line of intersection. Again, we're just going to repeat that process. So this time I'm going to take the line from point B. We've now got 2 points on our line of intersection. So all we have to do is join them up. And there is our point of intersection in our plan. So a purple line there. All we're going to do now is simply transfer it up into our elevation. And now we have our line of intersection on our elevation also. So the next thing we're asked to do is determine the dihedral angle between the two planes. So to get the dihedral angle, we need to first find the true length of our line of intersection, and then we need to look along it to see the two planes as edge views. So for this, we're going to use our sliding set squares. We want them to be parallel with our line of intersection in our plan. And all we're going to do, so first we want to set up an x1, y1, which I have done here, an x1, y1 line. And then all we want to do is transfer all our lines into our auxiliary elevation. So I have DEF drawn in there, and I also have the lines for ABC brought across. Just to point out, when we're taking an auxiliary elevation, to get our heights we go 2 steps back. So with our compass, we're going to count back 1, 2 steps. So for the height of A in our auxiliary elevation, we're going to take the height of A in our elevation and transfer it down. And where the compass makes the mark there, that will be point A. So point C has just run a tiny bit off my page, so all I done was I got an A4 page, put it in behind the sheet and taped it up. Once we've all our lines brought across, particularly with our line of intersection, where it contacts line DF and also line EF, we can draw that line in, and that then gives us our true length for the line of intersection. The next thing we need to do, as I mentioned, is to look along the line of intersection. Set up our x2, y2 perpendicular to our true length line, and we want to project all these points from our auxiliary elevation down into our second auxiliary. So we're going to bring down all these points parallel to the true length line, like so, and that should give us, provided they're all plotted right, the edge views of our two planes. So once we've them two edge views, we now also have our dihedral angle. And we're just going to label that as well. The next thing we're asked is to show the projections of a line drawn from point E, which is here, or here for example, which is 60 millimeters long and is parallel to the plane ABC. It must also be inclined at 40 degrees. So for this, once again, we're going to take an auxiliary elevation. We're going to go to the right of the sheet this time, just for a bit more space. So what we're going to do is we're going to look along our line, our horizontal line. So again, we're going to take a horizontal line in our elevation, which we already have it from earlier on. And we're going to look along that line in our plan view, because any horizontal line in our elevation is going to be a true length in our plan. And we need to look along a true length line. And just like with any of our other drawings, we're going to set up our sliding set squares, and we're simply going to transfer all our lines, all our points, into our auxiliary. So bring them all in. Remember, they're all going to be parallel to this true length line. So we should be left with plane ABC as an edge view, and then we only need point E from our other plane. So again, we'll bring that line down. The next thing we want to do is from point E, we're going to get our protractor. We want to make sure that we have the 90 degrees lined up with our line coming from our plan. So with the line of E coming from our plan, and we're simply just going to measure 40 degrees either side of that line. Next thing we want to do is we're simply just going to extend them lines on out like so. The reason for this is because we know that an internal angle in here is going to be the same as the external angle out here. So we also know that this line is going to be 60 mil long. So again, all we have to do is get our compass, and we're just going to get it set to 60 mil, and we can make 2 marks along that line with the compass. And what we want to do is just enclose that, so we're essentially making a triangle, which really is actually a cone, because we're looking at it in the 2D. So we should now have a triangle, which with our extreme generator being our 60 mil, which is our true length. We also know that the line needs to be parallel with ABC. All that's left to do now is set up our sliding set squares parallel to ABC, and we're just going to slide them down to where they intersect point E, and we can draw in that line. So again, we want to bring these lines back into our plan. What we're going to do is we're going to take half of the base of our triangle in our auxiliary. I'm going to set that on point E in our plan, like so, and we're just going to draw a circle. We now know two possible points where this line intersects our cone up here. Where that line coming back into our plan cuts our circle that we're after drawing, we're going to project them lines up into our elevation. Again, we're going to take our height from our x3, y3, and we're going to step that off in our elevation. So we projected the two lines up in our elevation. We're just going to mark there with a compass on both of them, and we can join them 2 points now back to E. So the last part of our question asks us, on a separate diagram, draw the projections of skew lines AB and DE and show the projection of the shortest perpendicular distance between them. So what I've done here is I've went on to a new page and I've just set up the lines DE and AB. So before anything else, or the first thing we want to do is to take a copy of one of our skew lines and want to line it up that it's in contact with the other. So we're going to get our sliding set squares once again, and I'm going to set it up parallel to line AB, and I'm just going to slide the line AB over and essentially create that line that is touching point E, and we're just going to extend this line out to where the two intersect. What we want to do then is very simply just project that down into our plan. Now it doesn't matter which of these skew lines you copy across. For the sake of this example, I'm just going to take the line AB. So the reason we brought a level line here is because we know that a level line in our elevation is going to be a true length line in our plan. And the reason we need a true length line in our plan is so that we can look along it to get our auxiliary view. And also that means to see both these skew lines in a parallel view. And the reason we need them in a parallel view is that we can find the shortest possible distance between them. So all we're going to do is set up our x2, y2 line perpendicular to our true length line, and we're going to project points D, point E, point A and point B all up into our auxiliary view. And at the end of that then we should simply have two edge views that are also parallel. Again, our shortest perpendicular distance between these two lines could be anywhere in between them. So what we need to do is, again, we need to take another auxiliary, this time off the two parallel lines. Project all these lines, so A, B, C and D, up into that view. And once again we're going to go 2 steps back for our heights. So once we've that done, we're going to notice that our 2 lines are once again intersecting, which means that this point here, where the 2 appear to cross, is going to be our true shortest perpendicular distance. So all we have to do is we're going to simply drop that down into the drawing, into the auxiliary just before it. And there is our shortest perpendicular distance. And again, we need to transfer that back into our plan, and we can join that up as well. So that is our shortest perpendicular distance between the 2 lines in our plan. And again, we can transfer that up into our elevation. And that is going to be the line there. Once we've that done, that is our drawing complete.